This is the sign-in page of the I-NERGY load forecasting service. Two main user roles have been created using the Keycloak security framework. Namely, a data scientist and an energy engineer role are provided. Aiming to demonstrate both of them, we are about to log in as a data scientist, as the functionalities of this role are a superset of the energy engineer role. The I-NERGY load forecasting service is an AI service allowing data scientists to graphically trigger machine learning and deep learning pipelines for time series forecasting, while enabling energy engineers to visualize and inspect the results. The service has been developed using the React framework in the front end and MLflow and Feist API for the back-end functionalities. The sidebar provides access to the various functionalities of the tool, which range from load forecast pipeline creation to experiment tracking and system monitoring. All of them are available to both energy engineer and data scientist roles, except for the first one, which is limited to data scientists, as it requires modeling skills. Let us first showcase the sophisticated functionality that allows the creation of forecasting machine learning pipelines in a graphical way. Here, the data scientist can upload a CSV file of their preference containing a time series. Then they can select a variety of parameters to define the training procedure. As we can see, they can resample the time series to a different resolution as a preprocessing step, and they can define the train, validation, and test set split. After that, they can set the name of the experiment in MLflow under which the specific pipeline will run. Then they can select a machine learning or deep learning algorithm along with a desired set of hyperparameters. Those hyperparameters can be selected from a predefined list to ensure the feasibility of the execution. Finally, the forecast horizon can be set as it is necessary for the model evaluation process. The pipeline can then be triggered and the data scientist is prompted to the MLflow tracking UI in order to inspect its progress and detailed results. The ongoing and finished runs can be visualized here within the specific experiment. Additionally, there is access to hyperparameter values and the trained model per se, alongside evaluation metrics, plots, and other artifacts. Let us proceed to the experiment tracking functionality of the I-NERGY load forecasting service. This functionality is useful for energy engineers that need a quick overview of a specific experiment, as the first tab lets them fetch the best model that has been found within a specific experiment, chosen by evaluation metric. The user also needs to select a number of samples that they wish to include while visualizing the forecast versus reality plot. The user then gets a summary of the model's performance in terms of various evaluation metrics alongside the requested forecast versus reality plot that acts as a visual model evaluator. A second tab allows to examine the models of a specific experiment by entering the run ID of its respective evaluation stage. Finally, the System Monitoring tab gives the users an overview of the application regarding the available resources in terms of CPU, GPU, and memory. Therefore, it allows them to monitor the workload at any time. A profile dashboard is also provided, including user data and available roles. And in the end, a sign out button allows the user to exit the application.